This workshop is going to be covering test 4 for OJ20, which covers most of chapter 6 and a couple sections from chapter 5, the long division and synthetic division. Like I was mentioning earlier, I think the biggest problem with this test is there's so many types of problems and similar steps, and keeping them all straight is a little bit tough to do. So what this workshop really is going to cover is 1 or 2 examples of each type of section, and then we'll look at the steps for each one and then show you how to do those. So hopefully that'll kind of separate it. Like if you see this type of problem, this is what you need to do. Okay. So the first problem, it says find the domain. And our example says we have this function, x plus 3 over x squared minus 9. When it says find the domain, we're basically kind of interested in, is there any values that will give us an undefined fraction? Well, what value in the denominator will make it undefined? 0. 0. So all you're interested in is the denominator. The denominator cannot be equal to 0. So how would I solve for that?
Square root of 9 is 3.
Well, we haven't got to a point in O320 where we're taking the square root of both sides. We're going to factor x plus 3 times x minus 3 cannot be equal to 0. And then what would I do with those factors?
Set it equal to 0.
Okay, so in this case, not equal to 0. So what can't x be equal to here?
Negative.
And what can't x be equal to here?
Positive.
Positive. So those are your restrictions. Different instructors have different ways of writing it. There's interval notation. Most instructors are good to hear these restrictions. I think instructors like Ms. Shire, you put like all real numbers. Except negative 3 and 3. Correct? That's basically what we're stating here. So when we're finding the domain, are we interested in the numerator at all?
No.
No. You're just focusing on the denominator. The denominator cannot be equal to 0. And then you're just finding what values will give you 0, and then stating that domain. Any questions there?
So would you write that negative 3 comma 3?
No. If you wrote it in set notation, your domain would be x, where x would not equal to negative 3 or 3. You could write it like that. But I don't know how many instructors use that notation. Just depends on your instructor. But usually, I think most of them are okay with this
They can
statement.
put the comma in, and I just show the
Okay.
set notation, and I let them do it. My math lab does it like you did.
Yeah. So any questions on that one? Okay. Does everybody have that information covered?
So the only thing you're looking for is the domain, that's all it's wanting.
Yeah, it just wants the domain, which in this case, when you're dealing with a fraction, you're just interested in the denominator. Another type of problem is talking about reducing. So let's say you have x squared plus 3x plus 2 and x squared minus 4x minus 12. Right, the directions on this one might say reduce. or it can also say simplify. So if we just have one fraction like that, let's take a look at what it says. It says reduce or simplify. Completely factor numerator and denominator, and then we're going to cancel out common factors. So what would the top factor into?
X times X.
Okay. I'm assuming that.
Plus 1 is plus 2.
Plus 1 plus 2, I agree with that. Once again, that just goes back to factoring what multiplies to give me 2. That adds up to 3. That would be 1 and 2. We can do the same thing on the bottom, same factoring technique. Any factors of negative 12 that add up to negative 4?
Negative 6 and positive 2.
Okay. We have a negative 6 and a positive 2. So are my numerator and denominator factored completely?
Oh, yeah.
Yes. All right. So are we having any common terms there? Anything that can cancel out?
X plus 2.
Right. The x plus 2's are common. They're exactly the same. We can cancel those out. So what would my final answer be here?
X plus 1 over.
Why can't I cancel out those x's?
Because it's a unit. It's
Right.
together.
Right, Miss Allison likes to say it's a family. Right? You don't want to break apart that family, that x plus 1 is a family, x minus 6. We can't cancel out individual pieces there.
Well, that is addition, if it were multiplication, we could.
Yeah, if it was multiplication, you could. But addition and subtraction, you got to keep them together. Everybody okay with that one? Right. Just factoring, and then cancel out common terms. Everybody have that one? Can I erase that one? Alright, so let's do some multiplication. Once again, this one could say multiply, and sometimes in the book it actually also says simplify. But we will actually see that multiplication symbol between the two fractions. So we have 6 x to the 4 over 4y to the 9. That box there, that should be a multiplication symbol. The printer did not recognize the formatting, I guess. 12y to the 5th.
Because we don't have math calculators.
Exactly. It's on the wish list. All right, so we have 6x to the 4th over 4y to the 9th times 12y to the 5th over 3x squared. So it says completely factor all the numerators and denominators. Can you really factor with monomials? It actually makes it more confusing. So you want to leave the monomials as they are. Reduce the fractions and cross-cancel common factors. So is there anything that we can cross-cancel here?
4 and 12.
The 3 and 6.
Okay. So 3 and a 6. That leaves me with a 2, correct? Anything else?
4 and 12.
Let's do the 4 and the 12. So we're 3, right? What else could I do?
The x's and the lines.
Okay, so if I'm doing the x's here,
I'll leave you with 2x squared.
X squared is canceled, and X4 is X to
X to
6.
right, and x to the second would go up here, right? Because it was bigger up here. All right, what about the y to the 9th and the y to the 5th?
Y to the fourth would go on the bottom.
All right, there's more here, so y to the 4th. Okay. So once you reduce everything, we can just multiply across. If you are a visual person, colored pencils, right? It'd be very easy if you're using the same ink or the same pencil to lose stuff. But if you use different colors, it's very easy to see what you have left. So I have 2 times x squared times 3 on the top. So what does that give me?
6X squared.
6x squared. And on the bottom, what's the only thing we got left there?
Y to the 4.
Y to the 4th. If you do all your reducing carefully, you know, all of it, you will only have to reduce reduce at the end. So you take care of it here, you never have to worry about it at the end. Any questions there? No? Yes, again, probably chapter 6. Everybody seems to be okay. Let me guess, 6.3, 6.4? All right. Everybody good with that one? So let's try another example that involves a little bit of factoring. Once again, that little rectangle there represents multiplication. Okay, so let's read over the directions again. It says, completely factor all the numerators and denominators, if necessary. In this case, we do have a lot of factoring to do. Let's organize our information. 1, 2, 3, and 4. And off to the side, let's work those out. So 1, we've got 3y squared minus 3y. Any type of factoring I can do on that one?
Yes,
Okay, what could I do on there?
pull out 3y.
3y, correct. Greatest common factor. And what does that leave me with?
Y minus 1.
1 minus 1. Good job. So let's go down to 2. Three y minus 12. Any kind of factoring I can do there?
Yes.
3.
1 minus 4.
Y minus 4, correct. Part 3. Y squared minus 2y minus 8. Trinomial, coefficient of 1. Any factors of negative 8 that add up to negative 2?
4 and 2, negative 4 and 2.
Good job. Our last piece here says we've got y squared plus 3y plus 2. So once again, any factors of 2 that add up to 3?
1 and 2.
So y plus 1, y plus 2. Okay. So let's go back and replace our fractions with this new information. So we've got 3y, y minus 1, 3, y minus 4, y minus 4, y plus 2, y plus 2. All right. So we replaced all of our original fractions with our new information, all factored. Now it says we want to reduce fractions and cross out common factors and reduce. So is there anything we can cross out here?
Y minus 4.
Okay, I agree with that.
1 plus 3.
The y plus 2 is right. That's on the top, that's on the bottom. We can do that. Anything else?
And 3.
3, very good. Don't forget about the 3. Anything else that we can do there?
Nope, that's it.
Nope. So what do we got left on the top?
Y and Y minus 1.
And what do we got left on the bottom?
Y plus 1.
Plus 1. We took care of all of our reducing before we multiplied, so that fraction is reduced. And that's our final answer. I think the key to a problem like that is organization, right? It's very easy to lose a factor somewhere. So if you kind of list it off to the side, kind of shows, you know, it's very easy to just plug that information back in and go from there. Okay? Any questions on that one? This is another problem where factoring is very important, right? That whole factoring chapter, right? You don't have factoring down, This is a very hard chapter. Everybody have this information? Can I go ahead and erase it and move to the next one? Okay. Next part, we're going to talk about division. And there's a few different types of division problems. So let's start with the one where we actually have a division symbol in the problem itself. So we have 9x to the 4th over 4y to the 3rd divided by 3x squared. So if we have two fractions, we go back to like arithmetic. If we have two fractions and they're being divided, what do we need to do?
Let's multiply.
One of the phrases that Miss Allison uses, and I'm sure other teachers use as well, is the same change flip.
Yeah.
To keep the first fraction the same. Change your operation to multiplication, and then flip the second fraction. Okay. So now we're just back to what we did just a few minutes ago. We're just multiplying. We're going to reduce. So how can I reduce that? 3 and 9. In fact, I think this is the same problem. All right. So 4 and 8. Right?
Yeah.
This is 2. What about the x squared and the x to the 4th?
X to the second.
Okay.
Cancels.
And where's my x to the second going to go again?
Top.
Y to the 3rd and y to the 5th?
Y to the third cancels, and Y squared goes to the top.
Oh, this is a little different. All right, so what do I have when I multiply all that across on the top?
6x squared, Y squared.
Okay. Yeah, we got the 3 times the 2, which is 6, and then we have x squared and y squared. Do I have anything on the bottom?
Oh, 1.
I could put a 1 there, but is it necessary?
No.
No. Something like that. So basically when you have the actual division symbol there, the only thing that's different from multiplication is you just have to flip it over, right? We're just adding one step to multiplication. Just flipping it over and changing it to multiplication. Any questions on that one?
When it's, two different numbers, like you said, like the 9 and the x, or 4, you don't put those back together, you keep them separate. You keep the 3x squared separate from each other.
I just wrote it, I mean, I could have written it 3x squared here.
I know, but you wouldn't have been able to multiply because it's not much.
But like terms only really matters in addition and subtraction. So you can actually multiply anything together. I have 3x squared times 2y squared. That's still going to give me 6x squared y squared. You're only interested really in like terms when you're multiplying, or adding and subtracting. All right, so let's move to the next one. Once again, we have another division problem. We have a fraction divided by a fraction. The division symbol is actually there. So let's first of all do the same change flip. Keep the first fraction the same. Change to multiplication. And flip So what did I do with a problem like this for multiplication?
Factor.
Factor, right? That was like the second one we did on the multiplication one. I'm going to go ahead and list or label my information. I'll work that off to the side here. So what kind of factoring can I do on number 1? X squared minus 9. Difference of squares, correct? And what does that factor into?
X plus 3, X minus 3.
Okay. Number 2.
Factor out the x's.
So what kind of factor out there?
X squared, X plus 3 is
Just the greatest common factor. On number 3, a little bit of work to do there.
Factor out the X.
Right. Remember, you have to factor out a greatest common factor first if there's one available.
X squared plus 9X plus 2, and then factor that out.
Right. Can that factor further? Are there any factors of 20 that add up to 9?
5 by 4.
Very good. And on this last one, are there any factors of a negative 12 that add up to a positive 1?
43 plus 4 minus 3.
Once you have everything completely factored, let's go back and replace the information. I'm running out of room there, so I'm just going to go here. X plus 3, X minus 3, X squared, X plus 3, times X. X plus 4. So we have everything completely factored. Now what do we want to do?
Cancel.
Cancel stuff, yeah. So is there anything that cancels here?
X plus
X plus 3's cancel.
X minus 3.
X minus 3, right?
the x,
The X's.
X plus 4.
The X was 4, and so we did mention the X's. So I have an X here and an X squared there.
And
one
the
x on the
bottom.
bottom.
So I have a leftover X here. So what's the only thing I got left on the top?
X plus 5.
And what's the only thing I got left on the bottom?
X.
X. Can I divide that X into there?
No.
Nope. Right. And then X plus 5 is together, so we're going to keep it separate. Any questions on that one? Once again, it's basically factoring and organization. That's the two keys there. Make sure you factor correctly, organize your work, and you'll have all the pieces you need there to simplify that. So that's one type of division that actually involves the division symbol, but there's other types. So if we turn the page, or flip over the page. Everybody good with this one? Everybody have that information? So we have another type of division, it's division by monomial. But a lot of times it'll just say divide, define the quotient, something like that. But this one looks different. Still a division type of problem, but we have one single term in the bottom. So the way to actually set that one up, or one of the ways, is to actually split it up. In this case, into 3 separate fractions. Putting each piece over that monomial. And then what would I do from there? Yeah, I would just reduce all those fractions separately. 15 over 6 reduces down to what?
5 halves.
5 halves, correct? And then I have x cubed over x squared.
X at the top.
X at the top. Move to the next one. 12 divided by 6, that goes in evenly. What happens to the x squared? They cancel, they're exactly the same. 9 over 6,
3 halves.
3 halves.
X on the bottom.
Right, and the x would go on the bottom because I have one more left over. One of the x's would reduce, or cancel off, leaving with an x at the bottom.
You get,
And we'd have to leave it like that. There wouldn't be any like terms we can add together there. Notice this x is on the top, this x is on the bottom, so they aren't like terms. Any questions there? So if you have a monomial when you're doing division, just divide it into each piece separately. Any questions about that? Now, if this just said divide, this one's going to be division by long division. But how do we know we can't do what we just did?
It is a binomial.
It's a binomial on the bottom. Looks different. It's not a single term on the bottom anymore. So this one, and I'm sure your teacher will be nice and say divided by long division. So how would we set that up? So 2x minus 4 on the outside, right? And then we'll put it on the inside. 2x to the third. Oh, you caught it. Good. Why do I have to put a 0x there? Right, it jumps over. We start with x to the third. We go to x squared. The next piece should be an x, but it's not there. We have to put a placeholder in there. Well, why do we have to put a placeholder? If you're doing your division, if you don't have that placeholder in there, things won't line up correctly. It's very easy to get confused. So that's why we put that in there. So now we just look at this first term. What times 2x gives me 2x to the third?
2x squared.
I'm just going to go with x squared. Because if I put 2x squared, that's going to give me 4x squared. I just want the 2 there. So x squared times 2x.
2x cubed.
2x cubed. X squared times negative 4.
Negative 4x squared.
Negative 4x squared. What do I have to do with those terms?
Change that.
I have to subtract them, which involves changing the signs. Should that first piece always cancel out?
Yes.
Yes. So that's one way to tell if you change your signs correctly. 4x squared plus 4x squared is 8x squared. And just like any other long division problem, bring down the next piece. And we start the whole process over again. What times x squared, or what times 2x gives me 8x squared?
4x.
4x. 4x times 2x.
8x squared.
4x times negative 4.
Negative 16x.
Negative 16x. And I'm subtracting, so I have to do what with my signs? Change them. I'm just putting a circle around those, knowing that that's the signs that I'm using. So my first piece cancels out like it should. 0x plus 16x is
16x.
16x. Last piece to bring down. That was my last piece that I'm bringing down, so I have just one more division to go. What times 2x gives me 16x?
8.
8, yeah. 8 times 2x, 16x. 8 times -4,
Negative 32.
-32. Draw my line. Change the signs. So I have a -9 plus 32. 23. And what's that number called? And what am I going to do with that remainder?
Right over the line.
2x minus 4. And that would be my answer. So remember that that remainder, if you have one, has to become part of your answer. Any questions there? Can I erase that one? Yes. This one could say divide, but this one we're going to do by synthetic division. Now, why couldn't I have done synthetic division on the previous problem?
Because, oh wait, no. Because of the 2, right?
Yeah, because there's a number in front of the x, we couldn't have done the last one by synthetic. If you have a setup here where you have x plus or minus a number, you can do synthetic. So even if it said divide, that could be an option. So what's my setup here for synthetic division?
-2.
Where am I getting the -2 from?
Make sure you don't have equal 0.
Alright, so whatever makes this 0, it's the opposite of this number. What would my list of coefficients be?
3, 0.
Somebody died. Alright, your teacher might be tricky too. They might put in those placeholders, so be careful. Notice it went from x to the third to x. There's a missing x squared. So that's what we're going to put 0. X to the third, x squared, x, and then my constant term. What do I do with that first number?
Bring it down.
That first number always comes down. Then I go 3 times -2.
-6.
0 and -6 add together to give me
-6.
-6. Multiply -2 times -6.
12.
4 plus 12 is
16.
16 times -2.
-32.
Add those together.
-37.
Synthetic always lowers it down by 1 power. So what did I start with? What power did I start
X
with?
cubed.
X cubed. So this is now going to be
X
minus
squared.
3x squared, and then just write it in descending order. Minus 6x
Plus 16.
plus 16. That last number is your remainder.
-37 over x plus 2.
Exactly. You do the same thing we did in long division. Put the remainder over what you were dividing by. And that would be my answer. All right. Good on that one. Now we get to do stuff involving these common denominators. So now we get into addition and subtraction. Let's say we add these. X minus 4. So x minus 6 plus 3 over x squared minus minus 9. So let's go through the steps. It says find the LCD. It says remember to factor denominators completely. And then multiply each fraction by what it is missing. So can I factor the bottom of that left fraction? What does that factor down
Pull
into?
out 2.
1 and 2.
Times 3.
X minus
Correct. What does x squared minus 9
Difference
factor
is
into?
squared. X plus 3, X minus 3.
X plus 3, x minus 3. So, off to the side here, let's determine what my LCD be. What is my lowest common denominator?
2, X plus 3.
And then X plus 3.
Your LCD is everything that really shows up in your denominator. I have a 2, x minus 3, and then I have an x plus 3 that shows up here. So my entire LCD would be 2x minus 3, x plus 3. So what I'm going to do is write two separate fractions that have a denominator of what my LCD should be. Because now it's real easy to compare what I'm missing. So if I'm looking at this x minus 4, what is that missing compared to the LCD?
X plus 3.
X plus 3. Now that x minus 4 is a binomial, so you have to put it in parentheses there. If I'm looking at the second fraction, what is that one missing? Just the 2. So I'd have to multiply this one by 2 and that one by 2. So if I FOIL this out, right, I have a binomial times a binomial, what do I end up with?
X squared.
X squared. And then a minus 4x plus a 3x would give me what? Negative x. And then a negative 4 times 3. Thank you. And then the other one, 3 times 2 is 6. Now what can I do with those terms now that I have the same common
The
denominator?
inner and outer canceled out on that, the one that we just followed.
Well, no, a negative 4 plus 3 is a negative 1, right? So that's where that negative x is coming from. So what can I do with all my terms on these fractions?
Combine like terms.
Combine like terms and write it as one fraction. So let's move over here. X squared minus x minus 12 plus 6. What is that going to give me?
It's going to give you a negative 6.
All right. Thank you. Am I done?
Yeah.
Because it says combine the numerators over the LCD, which is what I did. But the last step says reduce to lowest terms. The only way I can reduce it is if I have common factors.
Right.
So I need to factor that top.
X minus 3, X plus 2.
Right, that top factors down into x minus 3 and x plus 2. Factors of a negative 6 that add up to a negative 1, negative 3 and 2. Do I have any common factors there?
X minus 3.
X minus 3. So it does reduce. So what am I left with?
X plus 2.
Okay.
2 and X plus 3.
X plus 2. Correct.
2 and X plus 3.
And that would be my final answer. Okay. So once again, we found a common denominator. After we factored, we multiplied each numerator by what it was missing. We combined our like terms in the numerator. Then we checked to see if we could reduce it. Factor the numerator completely. We did have a common factor. We canceled it out. And our final answer was that reduced fraction. We good to go on that one? All right, so let's try subtraction. Who's been guilty of making sign errors on tests and quizzes and stuff like that? I better see a full classroom example.
Yes.
I do it. All of us have done it, right? So, to make sure we have this sign correctly distributed, what you want to do, change this to a plus and apply that negative to whatever that is up there. That's going to help us make sure that whenever we multiply by whatever's missing, we're distributing that sign correctly. So let's find our LCD, which means we need a factor. So we can take a 2 out of that one, right? X plus 5 plus. That's the difference of squares. So x plus 5, x minus 5. So off to the side here, I put my LCD. Any guesses on what that might be?
2x plus 5 and x minus 1.
So x plus 5, x minus 5. Very good. So I'm going to rewrite two fractions that have that denominator. So what is that first fraction missing?
X minus 5.
X minus 5. Once again, this is a binomial, so let's multiply that. What is the second fraction missing?
2.
2. So I'm going to multiply that by 2. All right, so let's FOIL this out. What do we end up with?
X squared plus 9x plus 20.
Minus A.
Oh, yeah.
Yeah, don't forget about there's a negative on that 5, so it's going to be a minus
squared
x.
minus x minus 20.
Right. And then I've got that negative 5 times 2,
Negative 10.
negative 10. Now I have two fractions with the same denominator. What can I do with the terms in the numerator?
Combine like terms.
Combine like terms. So I have x squared minus x minus 20 and minus 10,
It's going to be negative 30.
30. All right, see how it was nice that we already had that negative sign up there, so we know what signs to add. And then what do I need to do to see if I need to go any further?
Factor it out.
Right, so I have an x minus 6,
X plus 5.
x plus 5, correct? Do I have any terms that can cancel?
X plus 5.
So what am I left with on the top?
X minus 6 over 2 and x minus 5.
Awesome. And that would be the answer. Notice that addition and subtraction, the steps are basically the same. The only thing I did at the very beginning was I changed that to a plus and then distributed my minus sign to the top of the second fraction. Right? So the steps for addition and subtraction are almost identical. So let's move to the dreaded 6.3. All right, the complex fractions. Everybody good on that one? Trying to get at least one of these done.
No. We need all of those.
Huh?
We need all of those.
Well, I'm sure, but we got like this. This one might say simplify. We got 1 minus 2 over x minus 3 over x squared. Minus 9 over x squared. Now, this is where I might diverge a little bit from your instructors. Some instructors will want you to get an LCD at the top and an LCD at the bottom. and change it into a division. And I've also seen some instructors clear all the fractions out first and then reduce. So it just depends on your instructor. If you have a single term, my suggestion is to use the LCD of every single fraction.
X squared.
Right.
So my LCD here would be what?
X squared.
X squared. If I'm looking at my denominators, I have x, x squared, x squared. You always take the highest power. So what am I going to do with that x squared? I'm going to multiply both numerator and denominator by that LCD. I'll basically just distribute it. Actually, let me move it on the other side. That'll make a little bit more sense. So I'm just going to distribute. X squared times 1 is
X squared.
x squared. X squared times negative 2 over x.
2 over X cubed.
2x. It's actually just going to be negative 2x, but let's see why. If I have x squared times, and you can do this work off to the side, I can put my LCD over 1, right?
Right.
And then reduce that. So x squared and x
Yes.
leaves me with x. So I have x times negative 2.
Negative 2x.
Negative 2x, correct. Okay. X squared times negative 3 over x squared.
Negative 3.
It would be negative 3. And why is that?
X squared cancels.
Right. And if I have x squared times negative 3 over x squared, the x squareds will just simply cancel and leave you with negative 3. So what that step does is that's cleared your fractions out of the numerator. So let's look at the bottom. We basically have the same situation. X squared times 1, x squared.
Minus 9.
Right. X squared times negative 9 over x squared. The x squareds will cancel again, right? Leaves you with negative 9. So that step clears your fractions out. Then we want to see if we can reduce it. X squared minus 2x minus 3. Are there any factors of a negative 3 that add up to negative 2?
1 and a negative 2.
Yeah, 1 and negative 3. X squared minus 9. All right, it's a difference of squares. Do I have anything that cancels out there?
X minus 3.
Leaving me with?
X plus 1 over X plus 2.
Correct. Not too bad, right?
You did the same thing on the other example.
The other example looks different though.
It's
Okay.
stable.
Do I have any questions on that one? I got time for 2 more. Are you making that? I just want to make sure there's nobody. There's a class that meets here at 1:30. That's what I make sure. Oh, I guess we need some else there.
It is 5. It's like 5 minutes.
About 5 minutes left.
Oh, sweet.
That's only 120.
So we got 2A. Now, why does this problem look different
Is that?
compared to the last one?
You have only
Divided
one
instead of
fraction and then the
subtraction.
other had 2 fractions.
Right. Like the
Fraction
last one had
without
multiple fractions on the numerator and denominator. This one just has one fraction over one fraction.
The other one's fraction inside of it.
So would this mean the same thing? Let me write this. Does that mean the same thing?
Yeah.
Yes, right? If you have one fraction divided by this fraction, this essentially means the same thing. Well, what did we do with this type of problem earlier?
Flip it, change it.
All right, same change flip. And then I would just factor what I could and reduce. So can I do anything with that 2a? No. Not for the time being anyway. We're just factoring it. What about 2? Yeah.
You have 3.
I pull out 3, which leaves me with a squared minus 1. Can that a squared minus 1 be factored in further?
A plus 1, a plus.
Difference of squares. What about 3? Can I do anything with 6a minus 6?
So we take out the 6.
And can I do anything with that 4a
No.
as far as factoring? No. So I'll leave that like that. So let's rewrite this information. We've got 2a over 3, a plus 1, a minus 1, times 6, a minus 1 over 4a. Then we want to see if we can reduce it. Any common factors?
A minus 1.
A minus 1,
Is that 3?
the 3 and the what?
6.
The 3 and the 6, I agree with that. So 3, 6 leaves me with 2. Okay, the 2a and the 4a, what could I do with those?
It cancels the 2.
Right, I can cross those out and put a 2 here, right?
Not 2A, 2, 2.
Or the a's would cancel out 2. Can I reduce the 2 and the 2?
Yes.
Yep.
Multiply.
I can do a double there. Those 2's would completely
So
cancel.
you can do it on the top and bottom?
Yeah, anything on the top row, anything on the bottom.
Only in multiplication.
Only multiplication.
Okay.
So, what do I have left?
You have a,
A plus 1.
Now, I have that a plus 1 on the
but
bottom.
it's 1 on the top. You have
Yeah,
one.
if I have a denominator, I have to have a numerator, so I put a 1 there. Because things that divide out evenly, like this 2 divided by 2, that's a 1, so we'll put that there. So notice if it's a complex fraction, there's 2 different ways you could look at it. One is if you have the multiple fractions, like that first example. And if you have a fraction divided by one fraction, you could actually work it out this way. Any questions on that? Let's try, we got one more problem to do, I think it's with the solving.
Oh, use the thing.
Those of you taking a test at 1:30 might want to see this.
Yeah.
Let's go through the steps. Find the LCD. Remember to factor the denominators completely. So what does that factor down into? X squared minus x minus 1.
4 and 3.
Okay?
4 minus.
Because you have x plus 3, x minus 3, correct? And equals 2 over x minus 3, x minus 4. So what would my LCD be here?
X minus 4, X plus 3, and X minus 3.
And since I'm solving, I have to put some restrictions on what my x value can be. Right? Remember, these denominators cannot be equal to 0. They make them undefined. So my restrictions would be x cannot be equal to 4, x cannot be equal to -3, x cannot be equal to +3. Whatever would make these factors 0. So after I'm solving, I have to make sure that my answer doesn't make one of those. Yeah. So there's a couple different ways to do this, but I think most of the instructors take the LCD. And multiply it times your entire equation. I have an equation, so I can take my LCD and cancel out as I'm going along. So if I'm looking at this LCD and this denominator, what's the only piece that would be left over?
X.
X minus 3, right? The rest of them would cancel. So 4 times x minus 3. Looking at my next fraction, what pieces would cancel? What do I have left over?
X minus 4.
Right, the x plus 3 and x minus 3 would cancel in with x plus 4. So 1 times x minus 4 equals, what about that last one on the other side?
X plus 3.
X plus 3 would be the only thing that's left over. So just like the complex fractions, multiplying by that LCD clears your fractions out. Now I just multiply out what I have left. 4x minus 12 plus x minus 4 equals 2x plus 6. Combine like terms. 5x minus 16 equals 2x plus 6. So subtract 2x. Add the 16. 3x equals 22. So I think somebody said that x equals 22 over 3. Is that any one of my restricted values?
No.
Yeah. Those are the only 3 that showed up. So my answer would be 22 over 3. What if this was one of the restricted values? What would I have to put? Not undefined. No solution. So if I got an answer, say I got an answer of x equal to 4. What would I put?
No solution.
No solution. All right, if your answer is one of your restricted values, you toss it out, and in this case, there would be no solution.
But if it's 0, then it's,
Zero.
Yeah,
Zero
if
would be your
x,
answer.
0 is fine as long as it isn't one of your restricted values. All right, we're not going to have the rest of those last 2, but good luck on your test for those of you taking it at 1:30. I hope this helps.
Yep. We good.
All right, cool.